All right, so today we're going to look at 6.5, and this is broken up into two lessons. We're just going to do the part one here. We're dealing with complex numbers, so that means like imaginary numbers, but this time we're looking at them in polar form instead of in our rectangular form that we've done for years, worked with I in rectangular form. Now, this is kind of just an intro. We need to kind of master this and have this down pat, so that tomorrow when we do day 2 and it gets a little bit more intense, this is easy peasy. We just power through this kind of the grunt work of it. So how we've previously worked with complex numbers is it looks like this, and the A is like a real number, like 4 or something, and then you have this BI, so B is the coefficient on the imaginary part of that value. So this is a rectangular form. We typically will use a Z to indicate that it's a complex number. Now, if we think about complex numbers like graphing them, which actually is a whole another type of math, it's higher level math, but if you think of it as graphing it, instead of having an X and a Y axis, you call this your real axis, and this is your imaginary axis. So if you were to see something like 3 plus 2i, 3 is the real value, so you would plot 3. 2 is the imaginary value, so you'd go up 2, and it would plot a point. So this and this kind of have the same idea, almost like you're thinking of it as an X plus YI. And so when you start thinking of it like this, now you can think of it on a rectangular coordinate system. But really what we're trying to do today is think of this in polar form, or sometimes we call it trig form of a complex number. So we're back to combining the whole idea of X's and Y's to get to a point. I wrote A and B, but remember we just said could be X and Y. All right, so, but also thinking of it on a polar graph where R is your radius and theta is the angle that gets you to that. Now, if you look at it, thinking about what we know about right triangle trigonometry, ideally you could agree with me that the cosine of theta, so here's theta, cosine would be adjacent over hypotenuse, A over R. And I could rearrange that, multiply both sides by R, and A would be equal to R cosine theta. And the B, you could do the same thing here with sine. Sine of theta would be opposite over hypotenuse, so B over R. Now to isolate that, get rid of the fraction, take both sides times R. So B would equal R sine theta. So when I look at this A plus BI, what's really going on is A is R cosine theta plus B is R sine theta, and then I'd take that times I. So this is the form you're used to. This is rectangular form. This would be polar form, or what we call trig form. Now I'm going to clean that up. We actually write it a little bit differently than that. Let's take a look. Our rectangular form is this right here, where the A is like your X value and the B is like your Y value in that right triangle trigonometry. And then trig form, I've tweaked it a little bit from that previous slide. I have factored the R out. It goes out in front. And instead of putting I on the back end, for whatever reason, we put I on the front end of that. And this right here, this format is, you'll use this a bunch, you'll get used to this, but it's R cosine theta plus I sine theta. I've said it 1,000 times. I say it in my head even as I write it. R cosine theta plus I sine theta. This will always be a plus sign. Always, always, always. Now that doesn't mean that it can't go negative, like the value might go negative because the sign of something might be negative, but we always write it as a plus sign. So today what we're doing is we are just learning how to convert between rectangular and trig form. And we already did a lesson on this. The only thing that's different, okay, so we're these same four rules. This should look very familiar. I just copied this from a previous slide. These same four rules are going to apply. It's just that we're dealing with imaginary numbers instead of like ordered pairs like we did previously. This will be a nice little review before our upcoming test here of these four rules. You got to know these inside and out. All right, so here we go. What I am giving you is a rectangular form of this complex number. So this is ultimately my x, and this is my y. And what I want to do is I want to convert it to an r and a theta. So if you have the x and the y, you're coming over here looking at these four rules to decide which one should I use. Well, if I have x and y, this is going to be helpful to find r. This is going to be helpful to find theta. So I'm using these bottom two rules. So I'm going to come over here and I'm going to say r squared is equal to x squared plus y squared. So it's a 4 plus, this is going to go positive when you square it. To square a radical like this, you square the 2, that's a 4. Square the square root, that's 3. So 4 times 3 is 12. Oh, this is going to work great. I'm going to get r squared to be 16, so r is equal to 4. All right, so now I know what r is. And now I'm going to use the other rule, the tangent of theta is equal to y over x. The y value is negative 2 root 3. Notice I'm not including the I. The y is the coefficient on the I. Don't include the I when you write this. And the x is negative 2. Your negative 2's are going to cancel, and you get tangent of theta equals root 3. And we're lucky enough that that lands on the unit circle. Can you think about where would tangent be root 3? And hopefully you're thinking in your mind, oh, that would happen right here and down here. Now, which of those do I want to write? Well, it goes back to the original, and I maybe should have drawn attention to it, but maybe not. Now that we're here, it might make more sense. I have to look at where that is. That is a quadrant 3. If I were to plot that x and that y, I'd land in quadrant 3. So when I look at my graph, I want the quadrant 3 option. And that angle would be, oops, got the wrong pin there. That would make theta be 4 pi over 3. All right, now, previously we were writing ordered pairs or maybe writing equations. What we're doing now is writing the complex number. So this has to look like the trig form on that previous slide that I showed the two forms. I know my r, I know my theta. So here is my trig form of this. Z equals r, open parenthesis, cosine theta, so theta is 4 pi over 3, plus I sine theta. Now, this might look messy. You might feel like you need to simplify something. But the reality is if you try to simplify this up, all you're going to do is take it back to where you started. You don't want to do that. You're done. That's your answer right there. That is the trig form of a complex number. Now, remember, I've talked about this. Sometimes it works out nicer rectangular. Sometimes it looks nicer in polar form. Typically, this trig form or polar form is a little uglier than the rectangular form. But it has a purpose, so we'll get there. Right now, we're just kind of practicing that conversion. Let's try going the other direction here. So we're going to take this trig form right here. So now I can tell right here that that's my R value and my theta. These are always going to be the same. Those two angles are always the same. They're always going to be your theta. Notice it's a plus sign. Always is a plus sign. All right, now, since we're going the other way, we're going to be using our other two rules because we know R and theta. We can find X. So X is going to be equal to 2 cosine 5 pi over 6. And the cosine of 5 pi over 6 is negative root 3 over 2. Oh, times the 2, it's going to come out to just a negative root 3. So we know our x. Now you do the same thing. Y is equal to r sine theta. So 2 sine of 5 pi over 6. The sine at 5 pi over 6 is 1/2, which leaves me with a 1 for my y value. And again, not an ordered pair, a complex number. So somehow or the other, I got to get an I put in there. So what I'm doing is I'm writing this in that form x plus yi. So x is negative root 3 plus, I can put the 1 in for the y, but normally we wouldn't. We would just write I. And that really is our official answer there. Converting from trig form into rectangular form. And I'm cutting right there. That's it. That's all we're doing, using those same 4 rules, but incorporating that I in there and getting very familiar with that. So when you walk in tomorrow, we can hit the ground running with some higher level math tomorrow. So don't miss out. Be in class tomorrow. All right. Hope this all makes pretty good sense for you. Go get started on your homework. Good luck.